In this video, we're going to be finding the indefinite integral of a natural exponential function. First, we need to know the integration rule. It's in this form. The most basic rule is this, though. If you have e to the x and you want to integrate that and find the indefinite integral, it's just going to be e to the x plus that constant of integration. If that exponent becomes any more complicated than just 1x, we're going to have to use our u substitution, and that's where this form comes into play, and that's the one we'll be practicing in this video. So now we have e to the 3x plus 1, so that exponent function is a little bit more complicated. I'm going to set that exponent value to be my u value so that I can use u substitution and integrate in this form up here. So if I substitute 3x plus 1 for u, we're nearly ready to integrate. We just got to make sure that if our function is in terms of u, we want to integrate with respect to u, so we got to change dx to du. The way to do that is to go over to your u substitution and find the derivative. So the derivative of u with respect to x is du dx. The derivative of 3x plus 1 with respect to x is 3. I want to solve for dx so I can substitute it. So if we multiply both sides by dx and then divide by 3, we can solve for dx and substitute 1/3 du or du divided by 3 instead of dx. So that du divided by 3 is really a constant of 1/3 that I don't need to integrate, so we'll move that 1/3 out to the front. And now we have e to the u du, so we can integrate our e to the u with respect to u. So our identity, our integration rule, is just going to be e to the u plus c, and we multiply that 1/3 at the front, and then we back substitute our u value. So put 3x plus 1 in that u spot, and we're done. Let's try another one. So this time we have 5x times e to the negative x squared. So I'm going to take my exponent, and I'm going to set that equal to u, and then rewrite my function as 5x times e to the u. We want to substitute dx for du, so let's integrate our u. Derive our u. So I have the derivative of u is equal to negative 2x dx. So I'm skipping a step in there. So let's go back up here. If we're finding the derivative of u with respect to x, I always get du dx. And on the right side, I'm always deriving a function that has x in it with respect to x. So I'm always just getting a derivative. And I'm always trying to multiply both sides by dx to get rid of it in the denominator position. So what we can do is we can actually skip from here all the way over to here, since we know we're always going to be multiplying by that dx. So that's what I did here. So instead of writing du dx and then multiplying both sides by dx, I'm just going to say du is the derivative of this with dx attached to it. And so that helps us save a little bit of room in our paper, a little bit of time in our process. And now we can solve for dx. We're going to divide by negative 2 and not just negative 2x, because as we can see here, if I shift some stuff around and move the order of our multiplication, I'm going to put that x after e to the u. I'm going to take my constant 5 out to the front. We're not going to integrate that. And so we can see visually here that what we really want to substitute besides just dx is x dx. And as I can see, I can almost get that if I just divide both sides by negative 2. So by doing that, now I can substitute x and dx at the same time for the value negative 1/2 of du or negative du over 2. And now I can take that negative 1/2 constant, shift it out to the front, and multiply it by that 5 that's already there. So we got negative 5/2 out front now. And now we have our identity, e to the u du. We can integrate using our rule, and we just get e to the u plus c, multiply that negative 5/2 back in, and then back substitute our u value, which was negative x squared, and we're done. Let's try another one. This time, we're going to rewrite some stuff first. So we don't know how to integrate a quotient just yet. So I'm going to rewrite x squared on the bottom or in the denominator using a negative exponent. So instead of 1 over x squared, I now have x to the negative 2. And instead of having e to the 1 divided by x power, I can write that as e to the x to the negative 1 power. So after we rewrite, now we can go a little farther. We're going to take that exponent value and make it our u value and substitute u in its spot. We're going to derive both sides over here. Use that little shortcut. Just say du equals the derivative of this with dx attached to it. The derivative is negative x to the negative 2 power. And go back and see what we want to substitute. So I can actually substitute x to the negative 2 and dx at the same time if I just move this negative 1 over to the other side. So if I make it the opposite of what I got going on here, so negative du is equal to positive x to the negative 2 power dx. So now I can substitute x to the negative 2 and dx at the same time, and I'm left with e to the u times negative du, or just move that negative out to the front. And now I can integrate. E to the u du is e to the u plus c, and that negative gets multiplied back in. So now we just got to back substitute our u, x to the negative 1 power. We could write it in this form. We could change that form to this form. They're the same thing. Let's do one more example with some trig functions. So we're doing sine of x times e to the exponent cosine of x. Well, I'm still going to use the same process. I'm going to take that exponent of e and make it my u value. Then we can substitute it for u. I can derive both sides. So find the derivative of u. With respect to x, we could take a little shortcut and just say du is the derivative of cosine x with dx attached. The derivative of cosine is the opposite of sine. Let's go back and see what we can substitute here. Well, I can actually substitute sine and dx at the same time if I just move my negative. So the opposite of du is sine of x dx. So substituting all of that back in, I get the opposite of e to the u. I could take that negative out to the front before I integrate, or just remember that my integration is going to be the opposite. And then the last step is just back substitute our u again. So our final answer, negative e raised to the power of cosine of x plus our constant of integration.